Hello. Maybe I don't need the mic, but awesome. Thank you so much for making it to the talk, and it's going to be a lot of fun. The reason is because I have a bunch of swag as well for great questions. So great to be in Seattle and speaking at the Postgres conference. And my talk is going to be around overcoming common pitfalls of Postgres logical decoding. A quick intro of me before I get started. I'm Sai Srirampur, and I lead all the Postgres efforts at ClickHouse. And to folks who don't know, ClickHouse is the most popular open source analytical database. It is similar to Postgres, but more in the OLAP world, which is OLAP world. Prior to ClickHouse, I was the co-founder and CEO of PeerDB, and it was acquired by ClickHouse a few months ago. And at PeerDB, we built a fast and a simple way to replicate data from Postgres to other data stores like ClickHouse to support use cases like fast analytics, data warehousing, and so on. So for the past 1.5 years, my life has been immersed in logical decoding and figuring out how can we make it seamless for customers to replicate data from Postgres for enabling new use cases. Prior to PeerDB, I worked at Microsoft and Citus Data for 8 years, and I was a part of the Azure Postgres team. Before I get into the talk, I would like to give a quick primer on what is logical decoding in Postgres. Logical decoding is a feature that provides a logical stream of changes as they happen in Postgres to external clients. The stream contains messages that are simple like inserts, updates, and deletes. And clients can consume these messages to get a consistent state of the source Postgres database. It forms the basis of Change Data Capture, CDC, and helps power many real-world use cases. For example, replicating Postgres databases to other data stores like ClickHouse for offloading analytics, to Kafka for real-time alerting, and so on. So logical decoding also forms the basis of logical replication in Postgres. And as you guys know, right, logical replication helps with Postgres to Postgres replication and supports use cases like online migrations, online upgrades, and so on. Unlike streaming replication, which is more mature, logical replication is rather new and fast evolving. It has a bunch of caveats that users need to keep in mind while operating with it. Today, we'll do a deeper dive into these caveats and try to see how we solve them. The first one is beware of replication slot growth. And this is one pitfall that I will do a deep dive into, and 50% of the talk would be just on this, because this according to me is the most important one, and this is what we see while we work with customers who do CDC at scale from Postgres. Let's get into understanding what a logical replication slot is. A logical replication slot forms the building block of logical decoding. It captures changes happening in Postgres through the write-ahead log, also called WAL, and enables streaming of that WAL in a logical format. Under the covers, it basically keeps track of the WAL that's already consumed and that needs to be consumed by the client. And there are a few pointers like restart LSN and confirm flush LSN, which will actually help logical decoding keep track of that. An important point to keep in mind is that if the replication slot is not consumed properly by the client, it can grow fast, accumulate WAL, increase storage, and even can risk causing a crash to the Postgres database. So it is very important to keep the replication slot size in check. Here is a sample code which captures logical decoding in action. It's a simple Python code. There is more to this, but to give you an idea, right? The first box shows the logical replication protocol in action, where the client is continuously reading the replication slot, right? And then the second box is where the client confirms receipt of messages to the Postgres database. And that is also very, very important. We'll get into that piece very soon in the next steps. Let us now understand the common causes of replication slot growth, right? And this is based on the practice with customers. And the most common reason is a faulty client, basically. So a faulty client could be because of multiple reasons. First is, say, due to a bug or a crash, the client stopped consuming the replication slot altogether, right? Second, it could be because the client is not fast enough to consume the slot. And this could happen like for a bunch of reasons. Say like the client is constantly doing reconnections, right? And while like doing logical replication, reconnections are very expensive because a reconnection would start reading the wall from the beginning instead of like continuing from where it left off. The second is it could also happen if the client is in a different region as Postgres, right? It's a simple like collocation thing here. The third reason is that client is not implemented correctly. Say it doesn't periodically confirm receipt of messages by which the wall continuously accumulates and the replication slot grows. Long-running transactions can also lead to replication slot growth because like Postgres can't discard wall of transactions that start after the long-running transaction until the long-running transaction is decoded, right? This is because wall in Postgres is sequential and it cannot be flushed until the transaction before a given point, all the transactions are consumed. So long-running transactions are also like, a big cause of replication slot growth. Another reason for slot growth could be just the load. Say you're running a batch delete where you're like deleting like hundreds of millions of records at once. Logical decoding is a single-threaded process and it doesn't like keep up with the load on the database. No user activity on Postgres could also increase replication slot size. And this is due to auxiliary processes like vacuums, etc. that build up wall and the slot grows. So these are like, the main causes for replication slot growth in a production setup. And now that we know that replication slot growth is a common and an important issue, let us dive into a few tips on how to keep the replication slot growth in a check. The first set of tips are focused on the client. So how do we implement the client optimally to consume the slot like as efficiently as possible? The first tip is to make sure that the client is always consuming the replication slot and there is no idle time. Idle time means wall accumulation resulting in like, replication slot growth. Here is a quick query that I have which gives an indication whether the slot is being consumed or not. And the query should return true for every replication slot in your database. Once you see that it's false, it means that something is going wrong. As explained earlier, client reconnections also result in like replication slot growth. And this is because, as I said, right, like the wall needs to be read from the beginning instead of from the last point. So avoid reconnections while like doing logical decoding. Always make sure that it's running, right? And start replication is not like a long-running transaction. If you have start replication running for like 3 weeks, 4 weeks, 1 month, it wouldn't like block vacuums or anything like that, right? So you should make sure that your start replication command, the logical replication protocol, is always running on the Postgres database. Tip 3 is to avoid long-running transactions. And you can do this, either via configuring a reasonable statement timeout and where you don't have queries that are running forever, or you configure an idle in transaction timeout to avoid stale transactions that haven't been closed properly. This is one recommendation that we give often to customers. Tip 4 is to keep the slot moving in databases with no activity. To achieve this, you can set up a dummy heartbeat table that generates like periodic activity on Postgres. And in the example above, I have a table which is constantly getting updated like every 30 seconds, right? And if you see, I use the pgcron extension and I use the cron.schedule API, right? So make sure that like, you have a heartbeat table set up which makes sure that the slot is moving. Since Postgres 14, you can also emit a custom logical message to wall so that your client consumes that like, logical message and keeps the slot moving. A SQL function called pg logical emit message was introduced from Postgres 14, which allows you to emit custom messages to the wall. So that's another way you can actually make sure that the slot is moving. So this is very common in staging and dev environments, right? Like where customers like deploy Postgres like replication on like staging and dev, and they see that like if they don't do this after like 1 week, that slot is at like 100 gigs, basically, right? For no reason, right? Hence, it's important to make sure that you either you have a heartbeat table or like a logical emit message to make sure that the slot is like moving. Publication helps filter logical decoding messages before they are sent to the client, right? You can filter messages based on tables, columns, and even specific rows. Here you have examples which show how you can create publications for like, different scenarios, right? And the start replication protocol also takes the publication as an input, right? So this way you can filter changes before they are sent to the client, right? And that reduces network I/O and can improve, the logical decoding throughput. And that impacts in having like a smaller slot size. There are a couple of useful Postgres configs that help with like replication slot size. The first is max slot wall keep size, which defines the threshold of the replication slot size before it gets invalidated. And this helps avoid outages due to like storage limits being reached. The second setting which is useful is logical decoding workmem, which controls the memory that the logical decoding process uses. And if you're seeing I/O or reorder buffer like wait events on the logical decoding process, you can consider increasing this setting. I've shared like a link which provides like detailed guidance on how can you tune like logical decoding workmem. Tip 7, it's very important to like closely monitor the replication slot. And in PeerDB, like there is like a dashboard which just like does this thing where like it keeps track of like what is going on with the replication slots, and it also sends alerts like automatically to like Slack or like email if your slot size grows, etc. Right? And these are a few important like metrics. If you see, first is replication slot size, and there is a query that actually gets the difference between the restart LSN and the current wall LSN, and that dictates like the amount of wall that this replication slot is persisting, right? Second query, which we already covered, is to monitor if the slot is actively being read, right? And the third one is to monitor wait events for logical decoding to check if it's getting throttled for whatever reason, right? Like, and that is the pgstat activity, straightforward, right? And then that will give you like, okay, whether it's like throttled on I/O. I/O is the most common thing we see where like the slot is very large, right? And there is a reconnection. Like the wait event is I/O, there is reorder buffer, and it takes like, few hours to even get started with getting messages, right? Hence avoid reconnections. But then this query would actually, give you insights on that bottleneck. The fourth is to check the status of the slot, right? And then where like there is you can query like PG replication slots to get the wall status. And this gives you information whether the slot is like active, whether it's lost or invalidated, etc., right? So yeah, these are like some important like metrics that you need to do as a part of the monitoring process. And then few months ago, we open sourced like a tool called PG Slot Notify, which sends like alerts based on replication slot size. So you can actually, set up alerts saying that, hey, send me an alert if the slot reaches over 50 gigabytes, right? And the alerts can be sent to Slack or email. And this is something that we open sourced, and this is the same thing that we use in PeerDB under the covers, right? So every customer configures this. Like sometimes, like the error, the alerts might not be like significant of any issue, right? Like, okay, it hits 50 gigs. It could be just because of load. Okay, the customer is doing like a heavy backfill, and then it's fine, right? And sometimes, like it detects that okay, there is some issue with the logical decoding process. But this is pretty handy. Here is a more advanced tip, and you can use like logical replication protocols to reduce the rate of replication slot growth, right? And the start replication protocol provides you with like an input parameter called version, right? You can either specify 1, 2, 3, or 4, basically, right? And then each of them are different. Like one is the default, like, behavior where decoding starts only when there is a commit for a transaction, right? That's the standard behavior where decoding for a transaction starts only if it is finished, right? Version 2 lets you capture in-flight transactions, right? Like, so without the commit itself, like the client gets these messages and periodically flushes the slot, basically. And if you see, we conducted like, detailed benchmarks on how the replication slot size changes based on the version. As you can see with version 2, it took 20 seconds for the replication slot size to decrease, whereas with version 1, it took 200 seconds. So basically, if your workload has like medium-sized or like large transactions or interleaved transactions, using version 2 would be very helpful, because if you see the rate of growth, it's like 10 times lower when compared to V1, which is the standard, right? Now, the tricky thing about V2 is that like the transactional semantics need to be taken care by the client, right? Like, because it needs to see whether like there is a commit, etc., right? So that becomes tricky. We have like a PR out in PeerDB. It's a pretty large PR which does this, and this would take like logical decoding to the next level, right? And because it would like drastically improve throughputs, like it would reduce like the risk of replication slot growing, etc., etc. But the onus is on the client or the ETL tool basically to handle semantics, transactional semantics. So to summarize, these are like the 8 tips for keeping replication slot size in check, and all of these are like what we implemented in the past 1.5 years, at PeerDB. And then, and this is the slide, and you can quickly walk through these. So, yeah. Great question. So it started since, I think, Postgres 13 or 14, basically, where like the start replication protocol takes like version as an input, basically. And then with version 2, you can consume like transactions that are in flight. And the messages are slightly different. Like there is like, there are 2 types of messages for like transactions where like one is committed, one is not committed. And then the client needs to handle those messages, right? So at a high level, the way PeerDB does this is it maintains 2 queues, right? Like one queue is like committed transactions, and the other queue is like, ongoing transactions. And then it moves data from one queue to the other, right? Like that's the way like we handle like transactional semantics. It's a very fragile thing, right? Like it needs to be handled with care. That's the reason we are still like waiting for the PR to be merged. But like to answer your question, that versions were introduced more recently, and like they help with like faster flushing of the slots. Okay, so the second pitfall is like the popular pitfall, right? Like where logical decoding doesn't support like schema changes out of the box, right? And for example, if you add or a drop column, right? Like logical replication doesn't explicitly signal that, hey, this column was added or not, right? Like, and that becomes a bit painful, right? And to handle schema changes, clients can rely on relation and type messages that like Postgres gives, right? Whenever a column is added or dropped, logical decoding sends like a relation message to the client, right? And preceding the row, right? And then the clients can perform a diff between the old schema and the new schema using this relation message, and then decipher that, okay, these were the columns that were added, these were the columns that were dropped, etc., right? Similar is with like the type message, right? And this is very helpful when there are like data type changes, right? Like from int to big int, etc., etc. Yeah, PeerDB handles the relation message, basically. And then the type message is something that we are yet to do. But then the relation message, we did it. And then like, obviously it needed to go rigorous testing and like, because there are like a bunch of like edge cases, basically. So, yeah. No, schema changes is not yet like, shipped, basically. And the reason like Postgres did not ship schema changes is because of the default column. So the problem is the way Postgres operates is like either they do 0 or 1, right? Like which totally makes sense because Postgres impacts like this entire world, right? Like so because of the default columns where like if you add a default column, right? Like that's a bit tricky to get those messages into like the logical decoding message, by which like it's not supported out of the box yet, basically. Exactly, and that would grow the like wall crazily, basically, right? Like so, yeah. So in PeerDB, like the default case is not handled out of the box. So the customers need to like change and backfill like the previous rows by running like an alter table on like ClickHouse or like any target, basically. So The third pitfall is toast columns need replica identity full, basically. So toast columns are very large columns that can exceed like 8 kilobytes, and Postgres by default doesn't store unchanged toast columns in the wall. This is to ensure that the wall size is manageable, right? And by default, like logical decoding message like provides a pointer to the toast column, but not the actual value, right? And the client can use this pointer, go and like fetch that toast column, run a select star, whatever, right? Like and get that like toast column, right? And this doesn't become scalable when you have like millions and like billions of messages and you do those many round trips every time, right? Your logical decoding is streaming, but your like fetching of toast columns is like these many round trips, right? So this doesn't become scalable. Hence, the only solution as of now is to set the replica identity to full, and that would capture the entire like toast column value in the wall and in the replication slot, right? I shared a blog that explains like the impact of replica identity full on Postgres. It's a great blog from Zeta guys. And then the summary of that blog is it should be fine as long as your tables have primary keys. So setting replica identity full is fine most of the times if your tables have primary keys. With Postgres, like, 16, even just having indexes is fine, basically, right? Like because fetching updates for when replica identity full uses indexes. So there are more efficient ways to handle the unchanged toast columns in an ETL data replication setup without using replica identity full. For example, the client can maintain the state of the older toast columns and backfill them, right? Like, and the client can do this on the target. So basically say like you have ClickHouse, right? Like in ClickHouse itself, you can store what is the older toast like value. And then for a new like row that comes, which does not have this like toast value, it can fetch it from the previous like state, basically. And ClickHouse has this thing called aggregated merge tree with table engine, which lets you do this. We don't have that like feature yet, and we plan to do that soon. But at a high level, like if you have like an ETL setup where you're moving data from A to B, you can like handle this like unchanged toast columns by keeping state smartly on the target database, basically. So the fourth pitfall is that logical decoding skips generated columns, right? And generated columns are columns that are automatically computed based on values of the other columns. And these are sent as nulls in the logical decoding message. And to support generated columns, clients can compute, them through in-flight transformations, right? Like, so it's more a client-side transformation where like I get the row and I generate that new column on the client side. Or you can define a generated column on the target side. On Postgres, you can define a new generated column, or in like, ClickHouse, you can have like a materialized column, right? Like which under the covers, like, does the transformation for you. And in this case, like the transformation is pushed down to the target, basically. It's more like an ELT, right? Like where you load it and then the transform happens on the target. So I captured a few other caveats, like, and I wanted to say that like in pre-Postgres 17, logical replication slots didn't persist on major version upgrades and like failovers, right? Failover slots and like persisting replication slots on upgrades are a latest feature that Postgres 17 introduced, right? But then this works only for like 17 to 18 upgrades or like 17 to 17 replicas, right? It won't work for like 16 to 16 or like 15 to 16 like upgrades, basically, right? Like, so yeah, I'm very excited about this feature. So yeah, so these are like, the 6 common pitfalls of Postgres logical decoding. And there are a bunch. And today morning, like in one of the talk, it was mentioned that like logical decoding doesn't take care of like sequences, basically, right? Like, so there are a bunch of them, but these are the more common ones that we see in our day-to-day with customers. And yeah, so that's it from my end. And thank you for attending my talk. And I would love to take questions. So yeah.
I had a question about the unchanged toast column. I didn't quite follow what that example is. But under toast tables.
Yeah.
And then what's not changing, I guess, about the column?
Say you do an update where, so you have a JSON-B column, which captures a document which is very big, right? But then in Postgres, like you don't update that column. You update like some other column, which is like, say, Boolean or something like that, right? That update message once it goes through logical decoding, doesn't capture the value of the big JSON, basically. And that is the problem. So that is what I mean by unchanged toast columns not coming in the logical decoding message. By default, logical decoding message gives like value of every column. And that is what like, the replication tools, ETL tools use to replicate data to like different targets, right? But then the caveat around like unchanged toast columns is if you have a row that is for whom the update is not on the toast column, right? In that scenario, like it doesn't give the data of that toast columns.
Yeah, it could be potentially a gigabyte of data.
Exactly.
So do you think they'll ever add that as a feature? Like if someone wanted to opt into that, but I could understand why it wouldn't be the default.
Yeah, I think there are two reasons to that. One is like it by default like doesn't store in the wall, right? Like it has toast columns, it has these like pg_toast like tables, right? And then it has pointers to that basically, right? And then during recovery of the wall, like, Postgres like uses those pointers and does recovery. Wall is like for recovery, right? Like it's like, that's the crux of wall basically, right? Like it's for the D in like acid basically. So that's the way it works. Now, so one is like big wall is one reason. The second is on logical decoding, it increases I/O also, right? Like if you have like a super large document and you're pulling like this much, like it's not very efficient, right? Now, for Postgres to add this, like it is very foundational, right? Like, I mean, wall, better compression, like, stuff like that needs to change basically. But yeah. Yeah, that's a good question. So it should be available in the target, but then say you have like ClickHouse, right? Like, and then like I get like this. The way we apply that is like we do an insert directly in ClickHouse. Like even like an update is like put as a version insert basically, right? And then it becomes a bit tricky to, or not all databases support like upserts that easily on the target. Right? Like, for example, ClickHouse is an append-only store where you put versions, right? Let's take Snowflake. Snowflake, like, upserts are also not efficient, right? Like, where what we do is we do a merge command to get, like, the previous state, right? So the short of it is, like, Postgres need not send that information, right? But then it becomes tricky for, like, the ETL tool to implement that logic, because here we are operating across, like, different targets, like, with different, like, features, etc. So. Yes, exactly. And replica identity full is like more, I mean, from a practitioner standpoint, right, it's more a worry than, really I don't see it to be an issue, guys. Like I've seen like many customers at production grade using replica identity full and it's fine basically. But as long as you have primary keys, that's very, very important. If you don't have primary keys, it will do sequential scans.
Yeah, I was going to just mention like we have in some ORM generated, not generated, but in some environments, also create like join tables that don't have primary keys, and then we've had logical decoding issues discovering that later.
Yeah.
So I was thinking like running, kind of like preemptively running a query that's always looking for tables without primary keys or something.
Yeah, that PeerDB does that. So like we basically don't allow replicating tables without primary key or replica identity full. So like you will see it in the page where like, okay, these all tables will pop up, but they will be blurred out. So you cannot select them. But then if you hover through them, it will show that, hey, set the replica identity full or a primary key. So, yeah, these all like edge cases like we covered basically. I mean, that's what we have been doing for 2 years. Correct. Like, so we either like use replica, we tell the customer to get replica identity full, or like in ClickHouse, one great feature is materialized views. So like you can actually, and table engines. So like you can create like an aggregated merge tree kind of a table engine, which runs on an ingest basically, and then fetches the previous value of the toast column basically. But that is something that we leave it to the user as of now, and we want to automate that like in the future, so in the near future. So. Okay. Thanks. Thank you so much, guys.